And this next part just emphasizes what I was saying earlier. It says take note. You may question why a denominator of n minus 1 is used instead of n when we compute a sample standard deviation. The reason is that a sample standard deviation is often used to estimate the population standard deviation, and it can be shown mathematically that the use of n minus 1 tends to yield better estimates. So mathematically, n minus 1 in the long run works better than dividing it by n. Again, you're only dividing by n minus 1 if it is the sample. If it is the entire population, you divide by n. So what's the procedure? Well, the first thing you need to do is find the mean, okay? It doesn't matter if it's the sample mean or the population mean, just find the mean of the numbers that are provided for you. And then what you're going to do is you're going to take for each one of those numbers, you're going to calculate the deviation, which means just do the data minus the mean, okay? So the first one is find x bar. Find x bar. One sec, sorry. Find x bar, the mean, okay? Second one is do the data minus the mean. Data minus mean. Okay, the next one you're going to do is square it. Whatever numbers that you got, you're going to square it. Okay? And then it says, and add them. Square it and then add them together. The next one says divide by, if it's the population, divide by n. If it's the sample, divide by n minus 1. Okay? If it's the sample, divide by n minus 1. And then the last step is find the square root of that answer. Okay, so find the mean, do the data minus the mean, square each of those values, add them together. Then you're either going to divide by n if it's the population, n minus 1 if it's the sample, and then you're going to take the square root. I am going to ask that you do a couple of these by hand on the test, so I definitely want you to understand this process. All right? So let's look at it. Let's just do a simple data set. We're only going to do 5 data values here. In the real world, you'd be doing the standard deviation for thousands of values, if not tens of thousands or hundreds of thousands. But right now we're dealing with 5 values, just to show a simple example by hand. So it says find the standard deviation of the sample. Okay, so what does that mean we should do? Well, the first thing we need to do, first step is find the mean. Okay, so let's find the mean. How do we find the mean? Well, to find the mean, and first of all, this is a sample. We want to read that and make sure we understand. It says find the deviation of the sample. So that immediately should tell you, because it's a sample, that should tell you divide by n minus 1. So n minus 1 in this case, how many items do we have minus 1? We're going to divide everything by 4. We have 5 items, minus 1 would be 4. Okay, let's go back to that mean. The mean, we're going to add them together. 2 plus 4 plus 7 plus 12 plus 15. There's 5 of them, so we divide it by 5. Looks like I'm getting a mean value of 8. Please do so along in your calculator and double check everything. So that's my mean. That's the first step, very important step. You need that number. Now all we're going to do is throw our data values into this chart. So let's consider the data values 2, 4, 7, 12, and 15. Now I want to do the data minus the mean, and remember, we know the mean is 8 in this case. So we're going to do 2 minus 8, 4 minus 8, 7 minus 8, 12 minus 8, and 15 minus 8. Go ahead and do those in your calculator now. Let's see what values you get. I'm getting negative 6, negative 4, negative 1, 4, and 7. Okay. If we want, we could just double check real quick, add them together. It should be 0. So I get negative 6, negative 10, negative 11. Negative 11 plus 4 is negative 7, plus 7 would be 0. So it does check out. It does add up to 0. All right, so now what do? Take all those numbers and square them. Negative 6 squared is a positive 36. Negative 4 squared is a positive 16. Every one of these numbers should be positive. Make sure you're using parentheses. Negative 1 squared is a positive 1. 4 squared is 16. And 7 squared is 49. Okay. So that was step 2, was find the difference for the mean. Step 3 is square all the numbers and then add them all together. So go ahead and in your calculator do 36 plus 16 plus 1 plus 16 plus 49. Let's see what you get. Please double check my math. I'm getting a sum total of the deviations. The squares of the deviations is 118. So that's the end of step 3. We found the squares, we've added them together. Now we're going to do step 4. Step 4, we're going to divide by, because it was the sample, because it was a sample, it's n minus 1. And again, this is because it's a sample. We're dividing by n minus 1. In this case, it's 5 minus 1, which is 4. We already determined that. So what I'm going to do is I'm going to do 118 divided by 4. And then I'm also going to do step 5 at the exact same time. Never estimate that number right there. So if it's, this one's not going to be a bad fraction, but if it's a bad fraction, I want you to leave it as a fraction in your calculator, okay? Step 5 says once you divided it by n minus 1, in this case 4, you're going to find the square root of it. So divide it by n minus 1, leave that number, never ever ever estimate that number, and then find the square root of that. Let's go ahead and round our answer to, let's say, 2 decimal places. I'm going to reread and make sure it doesn't say. Yeah, it doesn't say what to round it to, so I'm going to round it to 2 decimal places. I'm going to say the mean is about 5.43. Please double check my math on that one. Make sure you're getting the same thing, okay? So 5.43 is the standard deviation. So what the heck does that mean? What does that mean? Okay, standard deviation is a measure of dispersion. So here's what we have if we're thinking about this. I want you to be able to picture this. We have these data values, and we've said the middle of these data values is 8. So the question becomes, where does everything else lie? So the idea is to add 1 standard deviation and subtract 1 standard deviation from both sides. So if I add 5.43, I think I would be at what? That would be a value of 13.43. And then I also want to subtract 5.43 from the mean value, which would give me 2.57 is what I'm getting. So what this means is the majority of the data lie between those 2 points right there if this has a normal distribution. So the majority of the data values lie between 2.57 and 13.43. So the standard deviation is not something crazy. All it is a distance. It's just a distance from the mean. It's saying add and subtract this amount, and that's where the majority of the data lies. How much of the data? Well, we're going to figure that out later, but I'm telling you it's over 80% of the data lies within those 2 values right there if your data set's large enough. And then what you would do is you would add and subtract another standard deviation, and add and subtract another standard deviation. And now you have this big range of numbers, and you can calculate what percentage of the data lies within these values by using standard deviation. So standard deviation is merely a measure of a distance from a mean, okay? So one thing I want to do real quick, it's not in here, but I want you guys to do real quick, is I want you to check this in your calculator. How are you going to check this in your calculator? Well, if you jump ahead in these lecture notes to, I believe it's page 5 in the lecture notes, it's going to show you exactly how to do it, but I want you to do it now. It's pretty simple. It's exactly like we were doing earlier. The first thing that you're going to do is hit data to enter the data into your calculator. If you see any numbers in your data, hit data a second time, and then hit enter to clear the list that had data in it. So I just hit data a second time, enter to clear list 1. I had something in list 2, so I cleared that out as well. Now I'm going to enter the data into L1. So in L1, I'm just going to hit 2, enter, 4, enter, 7, enter, 12, enter, 15, enter. So I've entered my data into list 1. Again, on my TI-30XS, I hit the data button, cleared out the data, and I entered the data. Now I hit second data for stats, exactly as we found the mean and the median in here. I hit enter for 1 variable statistics, the exact same thing I did for mean and median. I have my data in L1, and I want my frequency set to 1. So make sure your frequency is set to 1, and then hit calc. I want you to scroll down. Number 2 says X bar. That's our mean of 8. That's exactly what we got. Look at number 3. Number 3 says S of X. S of x means the sample standard deviation. And if we round that to 2 decimal places, your calculator shows 5.43, which is the exact same answer as we got. So we can use our calculator to double check all of our standard deviations. I also want you to scroll down one more, and I want you to see number 4 on the one variable statistics. You should see that sigma x. That is the population standard deviation. So this is where I was trying to emphasize on the previous page. It is extremely important that you know, is this a sample or is this the population? If it's a sample, you use number 3, S of x, and if it's the population, you use number 4, sigma x. Okay, so I hope that helps and you were able to follow along. Again, those directions for doing that are on page 5 of this packet.